Okay, next is function. So as name indicates, function means an activity, right, or something we have to do, or for example, making a cup of tea is a function, is an activity. Okay, it's a simple activity. So what are the things we need to make a cup of tea? Yeah, we need milk and sugar and water and etc. Okay, and we do the activity making tea, so we get an output. What is our output? A cup of tea, right? So that is simply a function, or it's an activity or a work or something. So mathematically, it is same. So so what we is a function means, or what is the question is what is a function. So the answer is 2 lines. So this is not a mathematical definition, it's only a concept. So in the second words, so the second line, the question is what is a function. On the second line, if we start off with an input and we apply the function, we get an output. So that is simply a function, right? We have an input, we apply an activity or a function, we get an output. So that process is called, or the activity is called what? A function. Some kind of activity is called a function, right? So is just mathematically, if we have to say that a function is a rule which maps a number to another unique number, right? So this is something what is called called a function, right? So as we go to the formal definition or mathematical definition, so a function means, suppose everything we are connected with the sets, right? So we go to set and we go to relation. Now we on function, right? So a function from a set A, so this is the formal definition. A function from a set A to a set B is a relation from A to B in which every element in A has a unique image in B, right? So that is called a function. So a function means a function from a set A to a set B is a relation from A to B in which every element in A has a unique image in B. So what is a function from A to B? As a short, we can say these 3 things. So a function from A to B is a relation. So it's a relation, and second is in that relation. So we know that for a relation we have what we mean by image of a relation, the concept of image. And so we say image for for each element in the relation. The second point is every element in every element have an image, right? Every element have an image. So second is, and that image is unique. Image is unique, or only one image, right? So that is simply we can say what we mean by function. So a function from a set A to a set B is a relation. First of all, it's a relation from A to B, and every element has an image, and every element has an image, and the image is unique, right? So a function from a set A to a set B is a relation from A to B in which every element in A has a unique image in B. Okay. So more mathematically, as a definition, we can say that let A and B be sets, then a function from A to B is a set F, right? So it's a set F, so of ordered pairs in A cross B, such that for each A in A, there exists a unique B in B with ordered pair AB belongs to F. Okay, so what is it says? Suppose A and B are 2 sets, then a function from a set A to B is another set F, right? So we notate that set by F, right? So F of ordered pairs A cross B, which means what? So is a subset, a function from A to B is a subset of A cross B, or it is a relation, from A to B. Now what is the property of that particular relation? Such that, that property is say that such that or having for each small element of A there exists a unique B in B with AB belongs to F. So for a particular now we have this F is a relation, right? Now ordered pair AB belongs to F means what? B is an image of A, right? B is an image of A. So such that for each A in A, there is a unique B in B with AB belongs to F means what? For each element in that relation, or F, there is a unique image in B. So means what? Every element having an image, and that image is unique. So that is called a function. So in bracket, in other words, if AB belongs to F and AB dash belongs to F, then B equal to B dash, which means what? Yeah, AB belongs to F is a relation, right? AB belongs to F means B is an image of A. AB dash belongs to F means B dash is an image of A, which means what? A and B have two images, B and B dash. Suppose AB and AB dash belongs to F, then what happened? Then what is the condition? B equal to B dash, which means what? A have only unique image. Which means let A and B are two sets, then a function from A to B is a set F. Is a set F of ordered pairs in A cross B, which means it's a relation from A to B, such that for each A in A, there exists a unique B in B with the ordered pair AB belongs to F, which means what? Every element in A has a unique image in B, right? So that is simply what we call a function. Now F is a function from A to B. Suppose if we take a function from A to B, then it's a relation from A to B, of course. So then that relation have domain and range. So then here the domain, suppose we have a function from A to B, then the domain of that function is nothing but domain of the relation as we view that F as a relation. Range of F means range of that relation F, right? So that is what we mean by domain and range of a function, right? So next we go to an example. Suppose A is equal to set 1, 2, 3 and B is equal to 3, 4, 5, 6. Then A cross B is a set with 12 elements, right? A has 3, B has 4, so A cross B have 12 elements. So consider F1. So F1 is a subset of A cross B, so F1 is a relation 1, 3, 2, 3, 3, 4, right? So now it's a function, right? So because every element, right, 1 has image 3, 2 has image 3, 3 has image 4, right? So every element 1, 2, 3 have image. What is the image of 1? 3. What is the image of 2? 3. What is the image of 3? 4. So every element in A has an image. Now 1 have how many images? Only one image, 3. 2 have how many images? Only one image, 3. So 3 have how many images? Only one image, 4. So which means what? It's a relation from A to B, and every element has image, and that image is unique. So F1 is a function from A to B. Okay, so consider F2. So it's a subset of A cross B. So of course F2 is a relation from A to B. So yeah, 1 has image 3, 1 has image 5. So which means what? Here also 1 have two images 3 and 5. So which means what? It is not a function, right? So F1 is a function from A to B, or F1 is a function, but F2 is not a function. Why F2 is not a function? 1 has two images 3 and 5. So F2 is not a function. So F1 is a function. What is domain of F1? Domain of F1 is 1, 2, 3. So yeah, every time domain of F1 is what? So if F is a function from A to B, then domain of F is what? A, because what? Every element has image. So if we collect first coordinates from F1, so it must be A. So that is the property of the function. So domain of F1 is 1, 2, 3. What is range of F1? Range of F1 is itself 3 and 4. Range of F1 may not be all B, right? So if range of F1 is what? 3 and 4. Okay.